Hey grade 9s, welcome to I guess the new way that I get to deliver a lesson to you guys, which is very strange to talk to an empty room, but that's okay. It's just kind of the way we're going to be doing things for a while. I want to remind you guys to make sure to go to Google Classroom at the start of kind of every school day or day when you would have science with me, just to make sure you're reading the instructions and what I want you to get out of your science for that day. So make sure you're going there. I'm going to be putting in everything you need there. So also make sure you connect with me during the Google Meets time, which will always be open for you when we would normally have science on that day. Sometimes I'll have it open other times as well. So again, you can use Remind guys to send me texts or email me if you have questions. But there you go. So what I want to do right now though is very quickly give you the lecture for topic 5 in our electricity unit. What we're going to be talking about in this lesson, which actually is presented very quickly, it's pretty short in terms of information, and if you were in the classroom physically, we would do a lab for you to more clearly understand what's happening. So in topic 5, guys, we're going to be talking about how these work. So of course, this is a battery. The topic 5 is called portable power. So we know that these batteries, which you will remember, are made of cells. So what we're going to be talking about is exactly what is a cell. How does it work? How does it provide the electrons that can flow in a circuit and give power to electrical devices? So that's what I want to talk to you about today. So we've got a few slides. We've got a few slides behind me that are going to help you. And of course, it's my expectation that you will have a digital copy of the notes package that you could either print off at home or you could complete digitally in the Google Classroom to be answering the questions associated with this topic. So let's get to the science. How do these things make everything we really rely on, like your phones, your electronic tech devices, your laptops, etc., how does that actually create electricity, flowing electrons? So first, guys, so hopefully when I'm out of the way a little bit, the lighting is good enough for you to be able to see the PowerPoint, but you know that you have this PowerPoint in the Google Classroom as well. So electrochemical cells are devices that can again change one form of energy into a different form of energy, which we ended off topic 4 talking about some of those things, right? Because we could use solar power, we could use mechanical energy, the energy of motion, to make electricity. Well, electrochemical cells, guys, that compose batteries, exactly the same kind of idea, except the input energy this time is chemical energy. So batteries or cells have some kind of chemicals, a chemical component that is ultimately going to provide the moving electrons for us. So the electrons will be moving through a circuit, and if we combine those cells, we know that we make a battery. Now, electrochemical cells have very simple components, really just 3 components. 2 of those components, guys, are what we call electrodes, which are most often metal strips, so just strips or of metal or discs, and 1 or more electrolytes, which are solutions of ions. Remember, ions, charged particles, right? So electrochemical cells can be classified as primary, which means they can't be recharged, like the typical AA battery that I'm holding. We know that kind of when it's done, it's done. Or they can be secondary, and secondary cells can be recharged. So like your phone battery or your laptop battery, we're going to consider those to be secondary. Also, cells could be classified as wet or dry. So a wet cell would have a liquid electrolyte, a solution of charged particles. If it's a dry cell, then it would use a paste or a solid that allows for movement of charge. All right, gotta move on to the next slide here. Okay, so let's take a look at the components of the cell, the electrodes, the electrolyte. So in this diagram, guys, we can see that we have a copper electrode and a iron electrode. So those are the two different metals we're using. We're using a copper stick and a iron stick of iron. And we have those hooked up, so they're connected by a wire, a conductor, which is going to allow the electrons to flow from one metal to another metal. Then we also have our electrolyte, and in this case, we just have one electrolyte. Sometimes you're going to see more than one electrolyte, like when you watch the video links that are in your student notes, it will take you to a YouTube video that will show you electrolytes that are separated, and it would have each metal electrode in its own solution. But it works sometimes if we just have the one solution as well. All right, so what ends up happening here is that the copper atoms, or the copper that might be in solution here, wants electrons, and the iron over here is the electrode that actually provides the electrons. So as the iron solid provides the electrons that will flow over to the copper electrode, the iron actually corrodes or disintegrates. So the mass of this electrode gets less and less as the cell continues. And guys, so this is one reason that your batteries can't last forever, okay? Because eventually you run out of the metal that provides the electrons. Now, as the iron disintegrates, the iron atoms become iron ions. And remember that iron ions are going to be positively charged. Whoops, so I guess I can't do that. It's just as bad as regular class. Okay? And the iron ions are positive because when something gives up its electrons, it has to become more positive. So this solution is getting quite positive. Over here at the copper electrode, which by the way we call the cathode, so electrons are always flowing to the cathode. A good memory trick is that the cathode catches the electrons from the wire, right? So the electrons are traveling through the wire and the copper cathode catches the electrons. Then there will be something in the solution that wants to grab those electrons. And in this case, it's going to be the water. Water contains, remember, hydrogen and oxygen, H2O. So the hydrogen part of the water, as an ion, the hydrogen ions, which are H positive, can grab the electrons and become the hydrogen gas. So we would actually see hydrogen, bubbles of hydrogen forming at the copper electrode, the cathode, because they're grabbing the electrons and going from hydrogen ions, H plus ions, to becoming hydrogen gas, and we would visibly see bubbles forming at this electrode. All right? Now, if I go to the next slide, we can see this time a different cell made of different metals and two different solutions now. So in this diagram, guys, we're still going to use copper. Copper is really good at wanting or gaining electrons. And so again, it's going to be our cathode. This time, instead of iron, we can have a piece of zinc or a zinc metal strip for this electrode. I didn't mention it before, guys, but the electrode that catches the electrons is called the cathode. The electrode that provides the electrons is called the anode. So electrons always flow from anode to cathode, like alphabetically, A to C. So in the solution over here, guys, we would have a blue solution because it's a copper sulfate solution, which provides positive copper ions and negative sulfate ions. On the zinc side, we have the zinc metal in a solution of positive zinc ions and negative sulfate ions. So when this cell works as a circuit, what happens is the zinc metal loses its electrons to copper simply because copper pulls on those electrons, and when the zinc solid gives up its electrons, it has to become zinc ions. And the zinc ions start to increase in this side of the cell, becoming more and more positive. If we follow the electrons, they're flowing through the wire. They might even be able to power, in this case it's a lamp. So the electrons are losing some energy to the lamp so that the lamp can do its thing. The electrons continue to the copper metal electrode, which the copper ions right here, the copper ions in solution, gain the electrons, and copper starts to build up. Brand new copper starts to build up on this electrode, which makes this electrode get heavier and heavier as the cell continues to work. So we've got the copper gaining mass because copper is continuing to form, but the zinc is losing mass as the cell continues to work. And so this electrode, there would be less and less and less of it. And if there's too little of it, eventually your cell would stop. Or if the solutions, if this becomes too positive, because remember it's getting more positive all the time because the zinc is becoming zinc positive, 2+, this positive, the increase in positive charge will pull the electrons back, because remember, opposite charges attract each other. That could also stall your cell so that it would no longer function, right? And then we always have to complete the circuit. So notice that there is a pathway for negative ions to move over to this side of the cell, because if these negative ions can't move, you would not have a complete circuit. And remember, electrons only flow if there's a complete circuit. So that's, we need some way for there to be a movement of ions on the bottom of the cell as there's a movement of electrons in the wire at the top of the cell. And that's how we're getting our electricity. So it's chemical energy, these chemical reactions that are helping generate electrons to be able to move or flow, creating the electric current. And it's as simple as that. Remember to watch the YouTube videos because it puts it into motion, and you're going to hear it explained again in another way, which is always good for your understanding. So thanks for listening today, guys. Make sure to do the work that I've assigned in the Google Classroom for this topic. And we'll see you next time.